Alright, so section 4.3 is on the properties of logarithms. And like everything else that we've done this year, this is not new information. You should have covered it in Algebra 2 and Advanced Math if you took that class. Honestly don't know if you only got through part of Algebra 2 if you would have finished this or not, but whether you learned it or not, it's not difficult. So there are 3 basic exponent properties that you need to learn, and the next lesson uses those properties to solve logs. So you've got to make sure that you know them. Alright, so first of all, the product rule basically says that if I have a log where 2 things are being multiplied, I can break it into 2 logs that are being added, which hopefully makes a little bit of sense because you know that you have this property. I don't know what I'm writing. Those are not the right letters. You have this property, sorry, for exponents where addition and multiplication go together. So with logs, it's the same concept. Alright, so we're going to use the property to expand. So we're going to say that we can write this as log base 6 of 7 plus log base 6 of 11. Now, if those are things that you could actually get an answer for, you could do that. Like if it said log base 2 of 8, then you could replace the whole thing with a 3 because 2 to the third is 8. But if that doesn't happen, then you just leave it. Alright, so for B, remember there's an understood 10 here. So we have log base 10 of 100 plus log base 10 of x. So base 10, so 10 to what power is 100? Since you can figure that out, you can go ahead and say 10 to the second is 100, so log of 100 is just 2. If you type this in your calculator, you would just get a 2. So I'm going to replace that log statement with what it's equal to, and then have plus this other log statement that I can't simplify. Alright, so our next property, if we have division inside of a logarithm, then we can expand it with subtraction. And again, that should look kind of familiar because if you divide like bases, you get to subtract their exponents. So it's related to that exponent properties. Alright, so to use the quotient rule to expand, anytime you have a fraction, you expand it with subtraction. So we're going to say log base 8 of the numerator minus log base 8 of the denominator. Alright, on B, we have ln of e to the 5th minus ln of 11. Alright, so remember that ln is log base e. So if it's base e of e, those cancel each other out, and this is just 5. E to the 5th is e to the 5th. And then this one, we can't do anything with, so we just bring it down. Alright, again, if you typed in ln of e to the 5th, your calculator would just give you 5. They're equivalent statements. Alright. So our third property is if we have an exponent, we can swing it out and multiply by it. And that is going to resemble this property, where if I have a power raised to a power, I just multiply those exponents. So it's saying that I have this many times. So when I do this, if I wrote that with addition, it would be using that product property, but we can just simplify it by using this property with the power rule. So what I mean by that is if I told you to do log, we'll say log base 3 of 5 squared, keep it simple. If I wrote that as log base 3 of 5 times 5, then I would expand it with addition. And then I could say that I have 2 of these things. So the power rule is honestly just a shorter version of the product rule if your arguments are the same. Alright, so how do we use this power rule? We are going to just simply say this exponent swings around to the front and becomes 9 times log base 6 of 3. I might be thinking that you could simplify this because these have something in common, but you can't raise 6 to a power and get 3 because 3 is not the square root of 6. You don't have any exponent that you can use. It's a multiplication relationship there. Alright, for this one, you have to first remember that the cube root is the same thing as 2 to the 1/3. So you have this property of exponents that's using. So we have a 1 here and a 3 here. So we have 1/3 as the exponent. So once you see it like this, then you can swing that 1/3 out front. Right, and then this one, we can pull the 2 out front and have log of x plus 4. And that's all that we can do there. Alright, so you've seen all of the properties. This is them all succinct and in one place. We're going to now do problems where you may have to use more than one property. Alright, so they want us to expand these expressions as much as possible. So you know that you're done expanding when all of your log statements only have one thing inside of them. Alright, so the first thing that we're going to do is realize that we have multiplication here. So it'll be log base b of x to the 4th plus log base b. I'm going to go ahead and call it y to the 1/3 instead of the cube root of y. Alright, so since these were multiplied, we expanded with addition. Now, both of these have exponents, so we're going to bring 4 to the front here and 1/3 to the front here. So it'll be 4 log base b of x plus 1/3 log base b of y. Alright, for the next one, you have a fraction, you have division, so we're going to first split it with subtraction, and again, I'm going to change the square root to x to the 1/2. Then we have minus log base 5 of 25 y to the 3rd. Alright, so here I can pull the 1/2 out front. Alright, here I have two things. These are being multiplied, 25 times y to the 3rd. So we're going to say log base 5 of 25 plus log base 5 of y to the 3rd. Putting those in parentheses because they go together, just to help keep the order of operations intact. Alright, so this piece is done. Just bring it down. Here, you see you have 5 and 25. Well, 5 squared is 25, so log base 5 of 25 is just 2. And then here you see you have an exponent, so we're going to pull that around and call it 3 log 5 of y. Sometimes people will want to add these. You cannot add these because you have to multiply 3 times log base 5 of y before you can add 2. And you can't really multiply these because we don't know what this is. Alright, so that's expanding. Your properties work to condense. These are the same properties you already wrote. Don't write them again. They just flipped them around and said if you have this, it can become this. Because the properties work both ways. Alright, so using your properties to condense. When you condense, you want one log with the argument looking pretty ugly, usually. Sometimes they work out nicely. So for this one, because they're adding, when I squish it back into one log, I'm going to do 25 times 4. So I have log of 100. Always stop and see if it'll simplify. So this is log base 10 of 100. So ultimately it's just 2 because 10 squared is 100. So log of 100 is 2. Right here, we have subtraction. So when we condense that into one log, we do the first one over the second one. So the argument here becomes the numerator, the argument here becomes the denominator. And if you could simplify that, you would, but you really can't. I mean, you can simplify this, but you can't simplify these, so there's really no point. All right. So a couple more. These are just, I don't know why they made it like it's different. It's not different. These just have coefficients. So before you can do anything else, your coefficients have to swing around. So we've got to write it as ln of x squared plus ln of x plus 1. Now we can condense the addition and say it's ln of x squared times x plus 1. So all of that is the argument. So it would be ln of x to the third plus x squared if you just distribute here. All right, so for B, if we swing this 2 around, we have ln of x squared. If we swing this 1/3 around, we have ln of x plus 5 to the 1/3, which just means the cube root of x plus 5. And then condensing the addition, this becomes ln of x squared times the cube root of x plus 5. Alright, and I think this is our last one. Nope, I was wrong. Alright, so we are going to swing this back around as an exponent. Then we're going to condense, so it'll be log of x minus 3 squared over x, because subtraction turns into a fraction. Alright, now the last one. We're going to swing our 1/4 around. And remember that a fraction always turns into a radical. As a fraction exponent turns into a radical. So this will be 1/4, so it'll be 1 and a 1 here, and the 4 here. So just the 4th root of x. This 2 comes around, and this becomes log base b of 5 squared, so 25. And this 10 comes around, and we have log base b of y to the 10th. Alright, so condensing that. You're going to start with log base b. Everybody has the same base, so it can all be put into one log. You have log base b of the 4th root of x over 25. And then you still have this piece. Alright, so when we condense that, you're going to have log base b. And you have this divided by this. So if I wrote out that I had the 4th root of x over 25, and I wanted to divide that by y to the 10th. That's really this times 1 over y to the 10th. So anytime I have a subtraction, it goes in the numerator. So this just joins the 25 in the denominator. I said numerator, I meant denominator, sorry. Anytime I have a fraction with a subtraction, it's going to be added into the denominator. So it'll be over 25y to the 10th. And then you're done with that one. Alright, so if I have a big string of subtraction, then I know the first one is the numerator, and everybody behind that is going to go in the denominator. Alright, so your assignments. Oh, I forgot the change of base formula. Alright, change of base formula is, like I really just looked at this and I completely forgot that was there. Change of base formula is kind of obsolete because your calculator, if you have the newer graphing calculator or the newer operating system on the graphing calculator, you can push out the window and it gives you a log base where you can type in whatever base you want. But if you're using like your cell phone calculator or a basic scientific calculator, then you do still need the change of base formula. So there's a lot on this slide. But basically your calculator has a log and an ln button. So if you have anything else and you need to be able to type it in your calculator, you have to use the change of base formula or alpha window if you have the new operating system on the TI graphing calculator. Alright, so change of base says that if I have this guy, I can write it like this. Alright, so if I have log base 5 of 7, as long as these bases match, and you should pick a 10 or an E, because those are the buttons that your calculator is going to have, then you can write it as log of the argument, the tall number, divided by log of the base, the short number. Alright, I can do that with log or with ln, which is what the bottom of this is saying. So I can do it with a common log, or I can do it with a natural log. And the reason we pick those, again, is because log and ln are the buttons that are on your calculator. So on your graphing calculator, there'll be the buttons beside the 7 and the 4. Alright, so using the change of base formula, can you figure out this guy? And we're not going to do it both ways. Like, pick one. I don't care. I always use common log. Some people always use natural log. It doesn't matter to me which one you do. Alright, but if we're going to type this in the calculator, we're going to have to do log of 2,506 divided by log of 7. Your calculator is going to put a parenthesis here. Make sure you close it before you hit divide so that your calculator does the right operation. Alright, so we have log of 2506 parenthesis divided by log of 7. And you get 4.022. If you type the same thing in your calculator, but with LNs instead of logs, you'll get the same answer. If you have the new operating system on your calculator, then you're going to push the alpha button and then the window button and choose log base, which is option number 5. And it will bring up something that looks like this. It'll have log, it'll have a little box, and it'll have a box. So you can literally type in a 7 in this box and a 2506 in this box and hit enter. And it will give you the correct answer. It'll give you the 4.022. Alright, now we should be done. So here is your assignment. If you have questions, please let me know when you start working through your homework problems. Some of them may be a little more complicated than the ones that we did, but it all follows the same basic process. So give them all a try, and then let me know if you have questions.